Indians are known for our taste in spicy food. Biryani is always topping the list of everyone's favorite dish. There is a list of ingredients that go into the making of biryani. The flavor and the aroma of each ingredient is enhanced when they blend with each other while cooking. Each and every ingredient undergoes a drastic change in its appearance, form, and taste. Now, let us give a scientific twist to the process of making biryani. All the ingredients blend with each other and hence they can be called the reactants. The reaction between these ingredients enhances in the presence of heat. The final product is your delicious aromatic biryani. Can we say the ingredients of biryani have undergone a chemical change? The reaction in which two or more substances, that is, the reactants, are converted into two or more different substances, that is, the products, is known as a chemical reaction. In the previous sessions of metals and nonmetals, we have learned about the physical properties. In today's class, we will learn about the chemical properties of metals and nonmetals. Chemical property is not something which can be determined just by viewing or touching the substances. The first chemical property is reaction with oxygen. Metals react with oxygen to undergo the process of burning. When metals react with oxygen, their respective metal oxides are formed. Let us see how a few metals react when they are burnt. Iron reacts with oxygen to give iron oxide. Calcium and oxygen react with each other to give out calcium oxide. Sodium reacts with oxygen to form sodium oxide. This is magnesium ribbon reacting with oxygen, and the product formed is magnesium oxide. When the ash of the burnt metal, that is its oxide, is dissolved in water and tested with litmus papers, you will observe that the red litmus turns blue. This indicates that the metals are basic in nature. Few metals like sodium, potassium, lithium, also known as the alkaline metals, are highly reactive. The metals like the sodium, potassium, lithium, they undergo instant corrosion when exposed to oxygen in air. Therefore, these metals are stored in kerosene to avoid such reactions. Just like metals, nonmetals also react with oxygen to form their respective oxides. Carbon reacts with oxygen to form carbon dioxide. Sulfur reacts with oxygen to form sulfur dioxide. Similarly, nitrogen reacts with oxygen to form nitrogen dioxide. When the gases evolved in such reactions is dissolved in water and tested with litmus papers, you will observe that the blue litmus turns red. This indicates that the nonmetals are acidic in nature. Phosphorus is a very reactive nonmetal. It starts burning the instant it comes in contact with oxygen in air. To avoid such reactions, phosphorus is stored in water. The next chemical property is reaction with water. Let us see how metals react with water. When metals react with water, their respective hydroxides are formed. Hydroxides are a combination of oxygen and hydrogen. During this reaction, hydrogen gas is also evolved. High amount of heat energy is always associated with the release of hydrogen gas. Sodium reacts with water to form sodium hydroxide and hydrogen gas. Potassium and water react with each other to form potassium hydroxide and hydrogen gas is also released. Lithium and water react with each other to form lithium hydroxide plus hydrogen gas. High amount of heat energy is released when rubidium and water react with each other, and the products formed are rubidium hydroxide and hydrogen gas. The reaction between cesium and water is explosive. The products formed are cesium hydroxide and high amount of hydrogen gas. Do nonmetals react with water? No, they don't. However, their oxides react with water to form acids. For example, carbon dioxide reacts with water to form carbonic acid. Nitrogen dioxide and water react with each other to form nitric acid. Similarly, sulfur dioxide forms sulfurous acid when it reacts with water. What is your reaction to all the information you gathered in today's class? Till we meet again, take care. Thank you.